Welcome to Lesson 4-6. That's Topic 4, Lesson 6. Today we're going to learn about inequalities. I know you're all dying to know what an inequality is, so let's talk about that. An inequality, look at that word inequality. It has within it the word equality. Oh, and everybody loves equality. And equality is just when things are equal. We make equations to show equality, like 9 plus 1 equals 10. There's an equality. Both sides are equal. Well, an inequality, well, that's everything else. Two quantities could be compared to each other such that one was less than the other. We call that less than. One could be greater than the other. We dealt with both these concepts when we talked about integers and compared integers. Well, sometimes things are less than or equal to. So for that, we have a less than symbol with a line under it, which kind of looks like a less than symbol, and bonus, an equal sign. Also, we could have greater than or equal to. It's going to look a lot like the other one. We've got a combo of a greater than and an equal sign right there, and that's that. There's one more possibility. The two qualities could just not be equal, and we put an equal sign with a line through it. We'll get more into each of these ideas later on, but those are it, the 5 possibilities for an inequality. All right, let's look at the situation here. We've got this awesome sledding hill. But if you are under the age of 8, you must be accompanied by an adult. It says so on the sign. So I want to try and describe the ages of the children who must be accompanied by an adult. They must be. Well, let's list some possibilities. If you were 1, you're probably not going sledding at 1, but if you were to, you would need an adult. If you were 7, you would need an adult. If you were, let's see, 6 years and 2 days, you would need an adult. If you were 3, you would need an adult. If you were 4 and a quarter years old, you would need an adult. I could keep listing and listing and listing of all the possibilities, and that's not really going to do for a mathematician. We want a more efficient way of expressing this idea. Maybe we'll try a number line. Well, again, I can go ahead and put dots where these things are. There's 1, there's 3, a little bit beyond 6 there. We have 4 and a quarter there. We have 7 right there. I could put dots all over the place on there, but I could not go beyond 8. 8 or more, I don't need an adult. We have a little more efficient way to express that, and that's with an inequality. And so the children who must be accompanied by an adult are all those that are less than 8. So if your age, I'll put an A for age, is less than 8, you must be accompanied by an adult. Now you see how that's way more efficient to write than either the number line or just trying to list every possibility there is. You can do the same thing, but with a slightly different question. In this case, I want people who do not need to be accompanied by an adult. And again, I can start putting dots on this. Okay, if you are 10, you don't need an adult. If you're 14, you don't need an adult. If you're 12 and a half, you don't need an adult. If you are 8 and a quarter, you don't need an adult. All these, I could keep putting dots all over this. All these people don't need adults. And even if you are at the age of 8, you do not need an adult. And so in this case, they're asking us to use n for the age. So n, if you don't want to have an adult, you have to be greater than 8, but you also can be equal to 8. Greater than or equal to, right there. That's how we could express this. Instead of listing every age up to 189 or however old you can live, that simple inequality will tell the tale. Okay, so now we have a whole bunch of inequalities, and we just want to put 5 points on the number line that represents the situation. So in this case, we want the length of wire is longer than 20 and a quarter feet. Well, 20 and a quarter feet is somewhere between 20 and 21, so I could just put, it doesn't matter, whatever, 5 dots there. Over here, the student is at most 30. So 30 is at most the biggest possibility. And then the other ones have to be less. Can't be any more than 30, at most 30. Got to read that carefully. In this one, C, we have the cost of the pizza is at least $8. Now, it could be $8 or more, right? If it's at least that, it's got to be that or more. And Zoe's age is not 11. So I can't put a dot on 11, but I can pretty much put a dot wherever else I want. It's just not 11. All right, for this next situation, instead of trying to graph it, we're going to write an inequality. So the length of a piece of wire, I'll use that cursive L, is longer must be greater than 20 1/4 feet. Okay, there you go, an inequality. The possible number of students, they don't give us a variable there, but I'll call that n for number of students, is less than or equal to 30, just like that. The cost of the pizza C will be at least $8, so the cost as compared to 8, it's at least, so it could be more, and it could be equal to. And then lastly, Zoe's age Z is not 11. It doesn't equal 11, just like that. Could be 12, could be 2. It's not 11. All right. So we have 2 more for you to try. Write an inequality to represent each situation. Harry's taller than 60 inches. Sherry's not 4 years old. See what you can do with that. We'll talk about it in class. All right, straight up practice here. You're going to write an inequality. I don't have that in the packet, but you're going to write an inequality for these 2 situations. The length of a fish a fisherman catches, F, must be at least 10 inches for him to keep it. Otherwise, you got to toss it back. And Sally's age, A, is at most 15. So go ahead and give that a try. See you next time.